So this is our video game that we've made called Mages. It is going to simulate the space conflict battle. There's two phases to it. One's a build phase and one's a conflict phase. There's also two different players in it. The first player is the blue side, which is a satellite constellation, and then there's a red side, which is trying to destroy those satellites. So the blue side, in the build phase, you can build out the satellites and build out the different assets that are trying to destroy those satellites, but also upgrade that technology on either side for blue or red. So that's kind of the build phase where you're building a bunch of things. The conflict phase is where you actually start to destroy the satellites from the red side. And the blue side is defending their satellites throughout their turns. So it's a very turn-based game that is in a 2D space. The next version of this is going to be actually training an AI agent that is going to be able to train to play each other against red and blue to be able to spit out a strategy. So this is a rapidly prototyping strategy engine that we're going to take and then give to a higher prototype engine. So that's kind of the end game of this, and I'm going to give it over to my colleague to be able to talk about the 2050 piece of this.
In Space 2050, there will be a multitude of assets, both from all sorts of actors from all areas. And so that makes space more congested and contested. And so with that, there will be a ton of data generated from all those assets. And that data will be way more overwhelming for any human decision maker to really parse through. And so what we need is AI data generation, and we'll need to trust that AI and trust that course of action being generated from AI and quantum computing.